Hello, welcome to this video on Java Virtual Machine. Let's get started. In this video, we will be covering about what is a virtual machine, what is a Java Virtual Machine or the JVM, what makes Java Virtual Machine the JVM special, and who are the JVM implementers or vendors. Let's start with defining what is a virtual machine. A virtual machine is a virtual computer which is running on top of an actual computer. Here, if we see this diagram, we can see that the actual machine will be running on the hardware of the machine, that is a host operating system, which is also called as the host OS or the machine, on top of which there is a hypervisor, and the hypervisor enables to install the virtual machines on the host operating system. The VMs share the resources of the host operating system like the RAM, CPU, the networking resources and the storage, and the hypervisor communicates the instructions sent from the VM to the host operating system. So as we have seen earlier, the actual computer is called as the host machine and the virtual machine is called as the guest machine. Likewise, the virtual machine shares the resources of the host machine, and the hypervisor is what acts as the intermediary between the virtual machine and the host machine. What is a Java virtual machine? Java virtual machine is also similar to a virtual machine, wherein it is also residing on top of the host machine. What it does is it takes the Java code or the JVM bytecode and converts it into specific machine code based on the host OS and executes the program that we have given to the Java virtual machine. And Java virtual machine is an abstract computing machine, which means there can be multiple different implementation of the Java virtual machine. Java virtual machine is just a set of instructions or standards which is specified so that you can have an industry standard for executing JVM bytecode. And because of this capability, Java virtual machine can be run on different operating systems and different platforms. Let's see how the Java code that we provide is getting run. So Java code we give is compiled using the Java compiler into JVM bytecode. This JVM bytecode is residing inside the class file, and we provide this class file which contains the JVM bytecode to the JVM, and JVM executes the class file. So while executing it, it converts the bytecode into the machine code specific to that platform. So for Windows, it will convert the JVM bytecode to Windows specific machine code. Let's see an example of how the code gets compiled and executed. So here we are seeing we have written a program to print the string hello world. It is residing inside a class called as hello world. So this code is written inside a file called hello world.java. Once we compile this code and run it, it gives the output hello world. So after compiling this code, it creates a file called as class file, which will have the name of the class name dot class. So the file extension will be dot class file. If we want to see the contents inside this class file, we have to decompile this class file using this command java p minus c class name dot class. So here it will be java p minus c hello world dot class. And as we can see over here, this is the bytecode. So the code, the Java code which was written gets compiled into the JVM bytecode, and this bytecode is applied to the JVM. As seen in the previous example, Java code gets compiled into JVM bytecode, and that JVM bytecode, which is residing inside the class file, is given to the JVM. What makes JVM special? As we know, Java platform has always promised architecture neutrality and portability. So the JVM specification promises that your code will be running with the same performance on any platform, and you can, once you compile it to correct Java, compile it to the JVM bytecode, it can be run on any platform. That is what write once run anywhere means. Next is high performance by the JIT compiler. There is two compilers. One is the Java compiler and the JIT compiler. So the JIT compiler is residing inside the JVM. That gives the performance, high performance to the JVM bytecode that is provided to the Java virtual machine or the JVM. And the last point is garbage collection, which is a important capability of the JVM. What is architectural neutrality? Architectural neutrality is nothing other than that the JVM can understand the JVM bytecode provided to it, and because of this capability, there has been the birth of many languages, and for example, like Scala, Kotlin, Clojure, and Groovy. So these languages are all JVM languages. Once you write the code in Scala, or Kotlin or any of these languages, it gets compiled into the JVM bytecode, and if you provide that bytecode to the JVM, it can run it. So these languages provide different capabilities. Scala was created for functional programming. Kotlin was created to reduce the ceremony of Java, and Clojure was written to write more closure and functional programming. Groovy was introduced to write scripting using JVM. So JVM can run your JVM bytecode on any hardware or operating system, and this capability is because of the POSIX interface specification. So POSIX interface specification is a set of industry standards which helps to maintain the same or give compatibility between different operating systems. So JVM is based on this POSIX interface specification. So as we had mentioned earlier, Java code, the JVM is processor independent, so it can run your JVM bytecode on any processor, Intel, AMD, ARM, Apple, or any of the processors. And it is also OS independent, so the code will give the same performance even if it is run on Windows or Linux or Mac OS. It is promised to give the same performance on all the platforms. Next is the JIT compiler. The JIT compiler is the compiler which is residing inside the JVM. So that is a runtime compiler. Once you compile your Java code using the Java compiler and provide the JVM bytecode to the JVM, the JIT compiler analyzes the code while the code is getting executed, or while the JVM is interpreting the JVM bytecode. It analyzes it and it tries to optimize this JVM bytecode, and once it optimizes it, what the JIT compiler does, it replaces the JVM bytecode that you had provided with the native machine code to provide better performance. So every time it doesn't have to convert the JVM bytecode into native code, it just replaces it with the native machine code, and the program gets executed much faster. The another important capability of the JVM is the garbage collector. The garbage collector provides a high reliable system based on the memory. So whenever the JVM needs memory, it can get the memory because of the garbage collector. So garbage collector silently cleans up the memory which is not being used, and it compacts the memory in the operating system. So what this helps us is that it prevents the host machine from going into memory issues, and it also helps the JVM in providing memory when it is in need of memory. As we had mentioned earlier, Java virtual machine is just a specification. It's an abstract machine, and many different JVM versions exist because of this JVM specification. Each JVM implementation is specified for is tuned for specific use cases. All of them have the same base JVM specification. It follows the rules, just that it has some edge cases where it can give better performance. Few of them are hotspot The main one is hotspot, and it is the most famous and widely used JVM implementation. It is provided as part of the OpenJDK distribution of the uh, Java platform, and it is developed by Oracle with the help of other companies like Red Hat, IBM, Microsoft, SAP, and many other individual contributors. Another one is Eclipse OpenJ9, which is from IBM. The next one is Azure's Zulu VM, which is from Azure system. So Zulu VM is for a special use case wherein it can provide better garbage collection. And the last but not the least, the Graal VM, which is the latest JVM implementation. It is also based on the Hotspot VM, and Graal VM is mainly developed by Oracle and the Oracle developers. So with this, we come to an end of this presentation. Thank you for watching this video. Till we see in the next video, stay safe.